Hello and welcome to the webinar. Again, I work with the Wildfire Learning Center. We're going to be on topic today with fuel treatment effectiveness and fuel treatment planning, and I'll be introducing the speaker in just a minute, but first I wanted to make a couple quick announcements. First off, this is part of a webinar series. It's about a bi-monthly webinar series, once every 2 weeks, and the Wildfire Lessons Learned Center, the International Association of Wildland Fire, and the Joint Fire Science Program co-sponsor the webinar series. And I put up links to their websites there, and please go and check out the growing amount of resources all three of these organizations are putting out there. All right, so first I want to introduce some of the upcoming webinars. And there's going to be, this is, the webinar we're having today is the first in sort of a two-part webinar series. Nicole Vaillant is going to be speaking about the ArcFuels program she's been working on, and then in July, Alan Egger is going to be giving the follow-up to that, talking about landscape treatment designer. So those will be two within and sort of on the same theme, covering some tools that the same group's been putting out. Also, we also have a group presenting on the MTBS project, or the Monitoring Trends in Burn Severity. It's a multi-year interagency project designed to map the location, extent, and associated burn severity of large fires occurring in the United States, that have occurred in the United States from 1984 to the present. So to lead that off, Josh Picott and Jennifer Lecker will give an overview of the MTBS project on June 19th, and then Eric Adula will give a presentation on how Grand Canyon has been working with the project on June 26th. Okay, so if you would like to register for those webinars, I've provided a link there. Obviously, you can click on the link, and that one's a hard one to type in. But that's the Advances in Fire Practice webpage. So if you Google Fire Practice, it will take you there. You can also navigate to it using the menu buttons on the side of the Lessons Learned Center website. And once you get there to the Advances in Fire Practice page, there's links to register for all those webinars. Okay, now on to today's webinar. I'll introduce the speaker in a second, but first I just want to show you how questions work. So if you see, it depends on what type of platform you're on, but either in the questions or chat box, you can type a question in. And we encourage you to type questions in, as the presentation's going. We'll get to the questions at the end of the presentation, and we'll try to work through as many, if not all of them, if we can. And so type them in, and then we'll get to them later. Just as a little quick check on that, if there are any groups out there watching the webinar, so if you have one registered person, but there's a group of you watching on, some sort of in a conference room, that sort of thing. We get lots of messages saying that there's groups watching. Please send me a message in the questions or your chat box and let me know how many people are in your group watching, so we can get an accurate count of how many people have are viewing the webinar. Okay, so you can get that in anytime you like. All right. So also, one last announcement, that the webinar is being recorded, so we record the webinar and then archive it. And so the link is up on the Advances in Fire Practice page for a week or two, and then we usually migrate it over to the Frames website, where they have provided us some server space to store all the webinars. And so I invite you to look through some of those older webinars too. There's a really strong growing collection of webinars on the Frames website, and you can get to that to that archive page from Advances in Fire Practice. Okay, and so you can also pass that link along to anyone if you like, if you think they might be interested in the presentation. So I'm going to go ahead and introduce the speaker now. Nicole Vaillant is a fire ecologist at the Western Wildland Environmental Threat Assessment Center and has served since 2001. Prior to coming to the center, Nicole worked as a seasonal wildland firefighter, including a season with the Reading Hotshots, and was a fire ecologist with the Adaptive Management Services Enterprise team. Her current interests include characterizing fire behavior at multiple scales, fuel treatment effectiveness, and risk analysis. Okay, so I'll change the screen over to Nicole now, and you can take it away.
Thanks, Josh. I want to thank everybody here for coming and attending the webinar. This is kind of just an overview of ArcFuels, what it is, how it works. It's by no means a training session. We typically do training sessions in those last 2 to 3 days to get a good handle on what the program does and how it works, and then you'll continue learning on your own as you keep working with the program. I'd also like to just mention right now Alan Ager is also one of the main people with ArcFuels. He is the one who started the whole system, and these days I tend to be the face of training more than anything else, training and testing. So there's a concept of fuel planning. It doesn't span, I guess fuel treatment planning works from a single stand all the way up to extremely large landscapes, can even be nationwide at the in scale. There's kind of this idea that stand level information is the foundation for landscape level fuel planning and fuel treatment effectiveness questions. After the stand, there's good information. We have good understanding of how fuel treatments and stands themselves alter fire behavior. We know that treatments that reduce canopy bulk density and increase canopy base height combined with a surface fuel treatment are typically most effective. This has been documented both in simulation and in actual wildfires. They've been known to reduce fire severity like tree mortality afterwards, as well as aid in suppression efforts during wildfires. So we know at the stand level fuel treatments are very effective. However, when we move up to the landscape, you have to think about the landscape as a whole. It's not just a bunch of individually burning stands. The fuel treatment effects can go beyond the fuel treatment boundaries themselves. One example study is Mark Finney found in 2005 that prescribed fire effects go beyond just the scope of the fuel treatment themselves. The figure on the bottom left has arrows pointing to the area where there's kind of this shadow effect where severity is reduced outside of the treatment units. And then Alan Ager, myself, and Mark Finney did another research project using simulation fire this time to look at fuel treatment effects on different stand characteristics in Northeast Oregon. And the graphic on the right just shows you that there is a massive reduction of expected loss of large trees within fuel treatments on the panel A, where the black lines are no treatment and then the white boxes are where it had been treated. But what was interesting is that reduced expected loss actually went beyond just the boundaries, which would be the panel on the right hand or B. So that was reductions in expected loss outside of treatments due to treatment themselves. So there has been kind of this shift from just looking at fuel treatment planning at the stand level to the landscape level. Why is this happening? There's lots of things that have been going on lately politically and as far as computer simulations themselves. We are now capable of doing computer simulations with large landscapes due to advances in software and computers. But one big reason of why the shift is wildfires are continuing to grow in size. For example, the Whitewater Baldy fire that's going right now in New Mexico is the largest in state's history. At this point, fire is no longer just affecting one or two stands. It's actually working at a landscape scale. Recently, Dave Culkin and others put out a revised cohesive strategy where there's the emphasis and a need for wildfire risk assessment and planning. They feel that at the different scales we do need to look at wildfire risk assessment for fuel treatment planning and effectiveness in locations, not just at the stand level, and this is a landscape concept. There's also a growing emphasis on large-scale landscape analysis for CWPPs, which are Community Wildfire Protection Plans. There's also this kind of question of fire and. I know we all like our fire and we have our blinders, but there is a point where we need to look beyond just fire and fuels effects and fuels treatments. We need to consider other aspects within ecosystems, watershed assessments and whatnot, and also funding. Money is a big point for everybody. There's been, at the federal level, a new focus on landscape restoration. So there was the creation of the CFLRP, which is the Collaborative Forest Landscape Restoration Project, where forests are given monies to help do fuel treatment reduction as well as restoration on large landscapes. And then there's the Integrated Resource Restoration, or IRR, budget planning, where there's a new focus for the money coming in FY12 on landscape scale restoration and also on non-WUI portions of hazardous fuels reduction. So we're looking beyond just protecting the homes and structures, but at a landscape scale for restoration as an agency with the Forest Service. So in order to do these landscape assessments, we need to use wildfire simulation modeling. why do we want to do wildfire simulation modeling? One main contention is that there's not enough large fires to quantify the risk at scales meaningful to managers. Yes, we're getting larger fires, they're occurring, but in order to really understand wildfire risk and probability, we still need to use simulation tools. It's also not always possible to test the effectiveness from wildfires at the landscape scale. It would be great to be able to go out there and design a landscape level fuel treatment and then burn off the watershed or landscape and see how the treatments actually affected fire behavior, but that's not always possible. One example of this was Omi and Martinson in 2009 did an assessment for Joint Fire Science looking at papers dealing with fuel treatment effectiveness, and they found very few actually had been burned by wildfires and then also had controls to do a solid assessment. So simulation modeling is still one great tool that can be used for landscape level assessments. But one thing that you need to do when you're doing these wildfire simulations is you really need to be knowledgeable. Understand the model that you're using and also their limitations. The limitations of a lot of the fire models have been highlighted in the literature lately, so just know what you're working with. Also know your data, so what you're inputting into the models is going to very much dictate what you get out of the models. And as well, once you start doing them, you need to do calibration. You need to either assess modeled output fire perimeters with historic ones, as are shown in the picture in the bottom right-hand corner. You could also do comparisons looking at fire sizes between actual and simulated. There's never going to be 100% agreement between simulation outputs and actual empirical data, but calibrating it so it's as close as possible is necessary. A few of the wildfire simulation models out there right now that are used at the landscape scale are Farsight, which most people know about. FlamMap as well is used mostly for fuel treatment planning, but can also spread fire across the landscape. There's also FSIM, which is a large fire simulator, which is part of the Fire Program Analysis System, or FPA. That's used more at large scales, like the national level or regional level. There's also FS Pro, which models burn probability in active burning wildfire events. It's used to do a lot of decision making. The key for this is really picking a wildfire modeling system that spreads fire, so something different than just doing a behave run or multiple behave runs on a landscape. There are quite a few spatial tools available right now to do a lot of this work for fuel treatment planning. ArcMap is starting to be adapted as the framework for modeling tools because of the ability to do spatial assessments. I'll admit I'm kind of biased. I am an ArcFuels person, but there are two other groups that are doing systems at work. One is IFTDIS, which is the Interagency Fuels Treatment Decision Support System. At this point, it's not quite fully functional yet, but it's getting there. It's a web-based system that kind of, when you log in, it removes the program interfaces, so you don't actually use ArcGIS or FlamMap or the other fire modeling systems. So in a way, it's a one-stop shopping. You can gather your data, do your analysis, and then output maps. However, there are some limitations within the program. One of it's the data availability there, and you can't fully manipulate everything like you could in GIS, which to me is a drawback, being someone who is very versed in ArcMap and its capabilities. Another set are the NIFTY tools, which is the National Interagency Fire Fuels Technology Team. They've got a couple tools. The first two, there's more beyond these that are listed, but the first two kind of deal with obtaining land fire data, which is grid data used for these landscape level assessments, and updating it. So there's LFDAT, the Land Fire Data Access Tool, which in my opinion is a great tool. It's a very easy way to download all the data you need for land fire to use in other systems. And then there's the Land Fire Total Fuel Change, which was formerly known as TOFU Delta for people. And this is used to update land fire data using layers within land fire themselves. And there's the new WFAT, which is the Wildland Fire Assessment Tool, which is the combination of the old FBAT, or Fire Behavior Assessment Tool, and FOFM-MT, which is a spatial version of the FOFM program that does first order fire effects. This is a great tool for characterizing hazard, but it doesn't do the fire spread per se, even though it includes FlamMap as its main fire behavior functionality behind it. It doesn't spread it. It's the basic fire behavior output, so it's like doing a bunch of behave runs on a landscape, and you don't see that outside of fuel treatment effectiveness. And then there's ArcFuels. So what is ArcFuels? ArcFuels is a streamlined fuel management planning and wildfire risk assessment system. It is an ArcFuels is an ArcMap toolbar. That's the way we distribute it. And it creates this great trans-scale interface. So you can use it for a single stand, or you can use it across a large landscape. And it applies various forest growth and fire behavior models within the GIS platform. It is also great for people who do a lot of landscape fire assessment. It eliminates a lot of tedious data transformations and repetitive steps, which can save a lot of time when you're doing analysis or repeated analysis. So ArcFuels itself didn't reinvent the wheel. It's more of a wrapper. What it does is it links and uses existing models. So the first would be, since it's an ArcGIS toolbar, it links ArcMap, and within it, it links the forest vegetation simulator, which is a widely used individual tree distance growth and yield model, which also incorporates the fire and fuels extension to FES, so you can do fire behavior modeling, fuel treatment planning in there. It has some fire effects, so even though it's not FOFM specific, it does give you information about expected tree mortality as well as smoke outputs. It also links the stand visualization system, which is a great way to actually visualize what a stand might look like according to the information that you input in the model. It also links to and opens a variety of wildfire models. So Nexus is a stand level wildfire model as well as Behave Plus. It also links to and opens FlamMap and Farsight, which are two of the landscape level fire simulation models I mentioned earlier. And it also does link to that FOFM, or the first order fire effects model, although it's not a spatial version like in the Nifty with that tool. This is just the stand level program itself. And then it also links to the new program that Josh mentioned. Alan will be doing a webinar in a few weeks on for the Landscape Treatment Designer, which is another product from WeTAC that helps design spatial landscape treatment plans. So ArcFuels is kind of designed around, the toolbar was designed around a fuel treatment planning workflow, where you kind of start at the left-hand side of the screen with your data acquisition. There is nothing specific to ArcFuels that allows you to get that data. However, there's other tools out there that are great. For the Forest Service folks, the FS-Veg Spatial Data Analyzer is a great way to gather tree list data to be able to run through FES for a landscape. And then also at the landscape, for stand or landscape really, and at the landscape scale, if you just wanted to use ArcGIS grids, that LFDAT or Landfire Data Access tool is amazing from Nifty. So the next step after you get your data, you've gathered it, is you want to critique or update your data. And then from there you would do model existing conditions, figure out your fuel treatment planning. Either you could already have a pre-planned alternative or find a way to know where to put your treatments. And then finally you'd want to test the effectiveness of your different fuel treatment alternatives. I should mention now that within this figure, all the black boxes are something that ArcFuels specifically helps with. So there are a lot of steps along the way that ArcFuels can aid in for the fuel treatment planning process, but there's also steps that are outside of the scope of ArcFuels itself. When you download the tool and all the user guides, there's a great section that we've written about obtaining and creating data sets so you can work forward with your own data in ArcFuels. Because ArcFuels is fairly data intensive, it is worth downloading the data set before, or the user guide before you get going. It can be run either with stand tree list data or grid data. You don't need both, which is great. So if you only have access to landfire data, that's absolutely fine. This tool can still work for you. Or if you've gone out and you've got common stand exam data, or you've done some monitoring where you have fuel plot data, you can also use that in ArcFuels. So it's versatile in the data needs. So I'm just going to go over a few of those steps real quick with ArcFuels screenshots from the data critique through the fuel treatment effectiveness. This first one shows that stand visualization. So I've got aerial imagery underneath a stand that I'm looking at in a landscape, and when I run through ArcFuels, it'll open up the stand visualization system and it'll show me this graphic of a stand, which is extremely great to be able to verify and understand if your tree list data is the same, because oftentimes it might be imputation. So there aren't as many tree list data as there are data points on the screen. The next one in there is a data query screen, where at that point you can click anywhere within your GIS map and it'll give you information about the stand from FES being the tree list or the fuel loading. And it'll also give you information if it's loaded about the landscape data itself. So if you downloaded those layers from Wildfire, you can click on any point and it'll tell you the elevation, slope, aspect, etc. for that given point on the map. It is similar to the identity tool within ArcMap itself. However, at this point it gives you the stand information as well, and it gives you the sandwich every time without having to change which layers are active. So once you've critiqued your data and understand what's there, there's a couple tools that actually help you update your data. The first, where the image is showing, is one where you can modify grids. So you can, within a landscape, you can modify any of the grid layers you have loaded, and you can replace values. So if you wanted to update fuel models within a fire, you can do that based on your own expectations or your own experience on what the wildfire had done. You can also do using a treatment adjustment database, which is used for more complex adjustments where you might alter more than just one grid layer at a time. So next, we would move to modeling existing conditions. The main key here for the landscape level is ArcFuels really facilitates the building of landscape files that are then used in the other modeling systems like FlamMap or Farsight. You can build those from either grids or FES, either data source. You can also use a mix of the data sources, which is very powerful. At the stand level, the main function of ArcFuels is you can do those FES runs, or the with FFE, which is the panel to the right of the text, showing that a selection of a stand. It then queries the information from a database, runs FES, and then it outputs these Excel workbooks that have all of the information from FES compiled for you, which is great, as well as a visualization. And the other thing at the landscape scale that's also wonderful is the post-processing. So you can convert those FlamUp outputs with a single step, and you can convert multiple at one time. So also with fuel treatment planning, there's the question of where do I put these fuel treatments. Sometimes you're given the fuel treatment itself. Other times you need to figure it out. So within ArcFuels, you can use FES to visualize those treatments. You can also use it to do a treatment analysis where you change one metric within a prescription file. So let's say you wanted to change the intensity of your thinning. So you're going to thin to a higher basal area target over time. You can see how that might actually affect different metrics like stand carbon, which is the graph at the bottom, or information like fire behavior, how that would affect fire behavior. You can also change fire metrics, so you can see how different wind speeds might affect your mortality for a given stand. For a landscape level, if you wanted to do it, you can use different programs like FlamMap. You can use the fire behavior to create a hazard matrix, or the treatment optimization model, which tells you kind of based on an ideal landscape where you might put your treatments given set restrictions, or you could link to the landscape treatment designer. So at the landscape level, the fuel treatment location is more external to ArcFuels. It just helps facilitate that information. So once you know where the fuel treatments are, you can actually use ArcFuels to assign prescriptions to FES. So if you wanted to run the forest vegetation simulator for the whole landscape, there's actually tools to be able to assign different prescriptions, so different treatments to multiple stands within the landscape, which is great. You can also use this treatment adjustment database where you have a grid of information that tells you not only where you want to put your fuel treatments, but how you want to treat them. And then it uses this information coupled with different treatment adjustments or replacements with the original baseline fuel layers, and then it updates them and creates a landscape file. You can also output these grids at the same time. So that's kind of when I talked earlier about the landscape change or updates for data. information. This would be the more complex way of doing it. So you could use it not only to implement your different fuel treatments, but to also update your data based on known disturbances or recent activities. And then finally, there's comparing, once you have these fuel treatments done, how do you look at your fuel treatment effectiveness? So again, one of the key things that ArcFuels does is it builds those landscape files for fire modeling. It also allows the post-processing of all the outputs from FlamMap as well as FarSight. And then within ArcFuels, what's unique is, to all the other tools, as far as I know, is this idea of wildfire risk assessment. It'll be coupled with FlamMap 5, which I've heard is coming out very soon. I'm keeping my fingers crossed that it is. But ArcFuels has tools that will actually post-process not only the ASCII files or grids that come out, but also these specific files called the fire size list, which is the location and size of all the fires burned at random when you're doing burn probability within FlamMap, as well as the flame length probability file, which gives you information on the gridded landscape about not only the likelihood of a fire occurring at any point, but then the intensity associated with it. So that information, or those files, will all be with the new FlamMap 5. Within ArcFuels, you can also calculate conditional flame length, which is the likelihood, or which is the flame length given a fire occurs, as well as expected loss. And expected loss is calculated combining FlameMap and then FES output loss databases, which there's information in the tutorial about how to do this, but ArcFuels links those two, so it not only gives you a form to run FES and create that loss database, but also then how to post-process the FlamMap files and then merge them together to calculate expected loss. It also lets you rapidly calculate averages for burn probabilities or intensity based on other polygons within the landscape, which is just very handy. So right now there are two versions of ArcFuels. There's one available still for ArcGIS 9, and then there's a new one for ArcGIS 10. They're distributed slightly different. The ArcGIS 9 is within an ArcMap file or an MXD, and then 10 is actually an Esri add-in file. They have kind of a different feel, but they're the same basic functionality between the two versions. The different feel is mainly because of changes to ArcGIS itself. So the change from ArcGIS 9 to ArcGIS 10 was quite major in the way ArcGIS was actually programmed itself. So that's what kind of prompted the change between us, or the additional ArcGIS 10 version of ArcFuels. So the big difference would be the scripting behind the two. There's also a couple minor differences in ArcFuels 9. We have what was called the treatment minimizer, which was used to build restoration fuel treatment patches. That's been replaced by just a linkage to the landscape treatment designer, which is kind of a version of the treatment minimizer, but much more robust. There's also, in ArcFuels 9, the risk tools were only available upon request, and now they're actually integrated within the whole system for ArcFuels 10. A lot of that has to do with the timeliness of FlamMap 5 coming out. So you can obtain ArcFuels on our website, which is arcfuels.org. When you go to the downloads page there, you can get not only the toolbar, but you can also download complete demonstration data. And I know some people who have heard of ArcFuels are kind of sick of seeing that Mount Emily landscape, but it's sticking around for a while. We also have available the forest growth and fire behavior models that you need to run the tutorial itself and go through the demonstration data. There's also a user guide and tutorial and supporting documentation. So some of the supporting documentation are the help guides to FlamMap itself, a lot of the FES documentation, publications that have used ArcFuels. There's also supplemental information for GIS. Right now the Arc 10 doesn't have a tutorial. ArcFuels 10 doesn't have a complete tutorial, just a user guide. I'm waiting for the FlamMap 5 to be released to release the tutorial there, but a lot of the information within the ArcFuels 9 is very compatible with ArcFuels 10. It just might look a little different. So there's also this push to do distributed computing, or an idea where all the computing is kind of out in space. It's a bunch of computers or servers elsewhere that you connect to via the internet. It's great because it removes software requirements, so you wouldn't actually need ArcGIS loaded on your laptop to be able to run ArcFuels or other systems. It's also wonderful in the increased computing power and memory. You can process larger landscapes much faster without bogging down your own computer. Right now, IFTDIS does use this type of system. So in response, ArcFuels, we're trying to figure out how we could do something without being totally web-based, and we do this via the Citrix system for the Forest Service. So at this point, all the linked programs work. We have a way for you to set up your own files within Citrix. It's great because it's easy access to corporate data, so anything you have stored on the T drive or anything that's up there is very easy to use via Citrix instead of having to bring it to your desktop, do your runs, and then bring it back up to the corporate drive. Unfortunately, at this point, it's only limited to Forest Service employees, and you have to be on the network. So I thought I'd show our website again. It is a good place to visit on occasion. We do frequent updates. We love to hear back from people if you're having any problems with the program or if you're finding bugs. We do try and test it, but those do happen. So as bugs are found and fixed, we do post new versions of ArcFuels. Also, if people have ideas on how to make this better for their planning and their use, we're open to those ideas and often do change the program to reflect those. So if you want to know when new updates are coming about, we highly recommend that you join the listserv. So we don't slam your inbox. It's just periodical updates of things like this webinar occurring, or we just released a new version of the ArcFuels toolbar. You should check it out. So I'm going to do a few live demonstrations. Fingers crossed that they actually work. And then, so this is kind of a list of the different things I was going to go through. It'll be fairly rapid and fairly fast, but I just wanted to actually show the tool in use rather than just talk about it. But first, I'm going to just acknowledge Joint Fire Science for the initial funding, RETAC for continued support, and then also definitely thanks to John Anderson, who's been our programming guru over the years, as well as a list of people who have done a lot of testing, development, and documentation. So now I'm going to switch over to ArcFuels itself. So this is an open version of ArcGIS ArcMap right now. We've got the ArcFuels toolbar, which is, I'll undock it here so people can see it. So that would be the ArcFuels toolbar itself. We've got the demonstration data loaded from Mount Emily. So right now it's a file that has all the different stands within, draped over imagery of the area so you can get an idea of what it's like. The study site is actually in northeastern Oregon. I'm going to zoom in here to a stand to just show you some of the stand level functionality. So there's a little lag. I'll try and wait for things to load for you to see. So right now I zoomed into a set stand, and I'm going to show some of the stand level FES simulations. So I'm going to click the stand. I'm going to select a stand to run an FES. At this point, I've input a prescription, so it's the combo KCP that's going to do a thinning followed by a fuel move and then a prescribed burn in the end. And then it'll actually simulate a wildfire after all of that. I'm going to switch over to the FES options, where this is where you set up all so it knows where to look for the FES data. And it lets you set up things like the cycles, the years per cycle. You can choose your fuel model set. There's also a new addition where you can generate your tree list for a set year. So if you have inventory data from multiple years, you can grow it forward to a specific year, then output the tree list to use that for future simulations so everything's kind of starting at the same time point. You can also generate a cut list, so if you're interested in what you removed based on the fuel treatment itself, you can get that information out. If you don't like the fuel models that FES chooses, you can override those before and after treatment based on your knowledge experience. Then there's also a variety of outputs. You can view the results in the visualization, which I'm going to do. You can also generate spreadsheets with graphs, or you can generate input files for Nexus. I'm not going to show the input for Nexus bit, but I will generate the files in the visualization and the spreadsheet. So I just need to go toggle on my select tool, select my stand. First you'll see FES run through, which is that black screen, and then it's going to open the spreadsheet and the stand visualization system after that. So what's showing up front is that SVS image, so you can look at inventory conditions, which is what's showing right now. I can switch to show what it looked like after we did the cutting. So based on that image, you can tell it's a fairly robust cut. At that point, we removed a lot of the trees. And then we're going to clean up the understory fuels with, we'll say, pile and burn and move it or move off-site. And then we actually simulated a prescribed fire. So you can see how the fire affected the stand itself, and you can see the flames moving through. So these tools are great when you're trying to explain how a treatment might work, or better understand if you've written a file for FES, how the treatment affects the stand. And then finally, I'll move to a picture of after the wildfire moved through. So even though we did that treatment according to FES, we've got some mortality. That would be all the gray trees in the screen. So this is based on the assumptions with FES that are built in and on that prescription itself. So there are ways to alter your prescriptions within FES and retest and recheck. So in addition to the visualization, there is also this workbook that's generated. It's a great compilation of all the different output files from FES. If you're familiar with FES, it just outputs a bunch of text files that can be kind of hard to go through and understand what's going on, but this compiles them all into one workbook, which is great. And in addition to that, it'll go through and it'll make, if you so choose, graphs of your information. So you can visualize how, let's say, surface flame length, which is the upper left-hand corner graph, changes over time. You've got the flame length on the y-axis, which is your feet, and then years across the y-axis. So it shows you how the fuel treatment affected it, as well as the wildfire, and just how time affects your different stands. You can do this with and without treatments. So next, I was going to show just a quick tool within ArcFuels that can be used to compare treatments. So let's say you have a couple of different treatment prescriptions out there. You can go through, and I'm going to go again to stand, and then I'm going to go down to the select stand FES compare treatments. So this time I'm comparing that same fire treatment to one where there was no treatment, but then a wildfire was simulated. So again, I need to then go select the stand. I'm going to use the same stand within the ARC map, and it's going to run FES through twice this time. So you'll see that black screen run through 2 times as it's doing FES, and it's going to open a spreadsheet that compares the treatments between the two stands. It can take a moment, so we'll hold tight while it's making that spreadsheet. So the first form that opens up after the 2 runs is this ArcFuel specific, and it's a way to compare carbon outputs within from FES. So it's a great way to show untreated and treated before and after with all the different carbon pools, which is a great tool if you're needing to do carbon analysis for your fuel treatment planning. Another one we'll look at is the FES compute output. So this graphs then different information that's within one of the calls or computes from FES. So we've got severe flame length, canopy cover, height to live, etc. And it shows you the 2 scenarios. So you can see the differences between doing a fuel treatment and then simulating a wildfire in 2007 versus not doing a treatment, as well as kind of difference graphs between the 2. There's also information if you scroll down on the data itself, which is a great way to figure out fuel treatment prescriptions. So you can compare the untreated and treated landscapes to figure out how to adjust your grid data if you need for later if you only have limited stand data. So I'm going to close this out. And then one last tool within the stand function I'm going to show is that information on how you query the data within. So again, I'm going to go to stand. And this time I'm going to go to display details. So it's telling me that when I click the ArcFuels select bar, I need to now click somewhere on the map to get the information. I'll close that window. And then I'm going to click within that same stand again. And at that point I clicked. Now it's going to give me information on the tree list for that stand, as well as if you have the information loaded, the fuels data, so the fuel loading. But then what's different about this too is it also gives you information about those grid layers that you have loaded from, let's say, Landfire as an example. And it gives it for that exact point in the map. So it's a great way to kind of assess and look at your grid data as well as your stand information. So I'm going to close this form out. And then next I was going to show a little bit about updating within a set grid. Let's say you had a recent wildfire on your landscape. So that wildfire is that red block right there. I'm going to zoom into that. I also have behind that displayed the fire behavior fuel models from Landfire. So there's the fire again. The predominant fuel model in there is that dark blue, which would actually be the 165 or a timber litter understory. Turn the fire off so you can just see what's under it. So let's say that I can tell based on the data that the fire has not yet been, the data hasn't been updated for the recent wildfire. So I'm going to go under my tools option. So then I can modify the grid values. So I'm going to select that option there. I want to modify that fire behavior fuel model layer from GIS, and I want to replace that 165, we'll say, with a 181, which is kind of one of the slower spreading fuel models out there. I actually only want to apply it within that fire itself. So I'm going to use that fire later to make my updates, but I still want it to create a new grid based on the whole landscape. So I'm going to go ahead and just name it, and then I'm going to create the grid. So what ArcFuels does is it actually creates the grid and then it remaps it. So what we're seeing now is a new map of the grid where that olive green is kind of the new area for the 181, whereas still a dark blue would have been 165. So you can see the fuel treatment was made just within that fire area for that grid layer. However, you still have an output grid of the whole extent. So that's a great way to update information based on, we'll say, recent fires. So I wanted to just point out, after you've done your critique, let's say you wanted to run FVS at the landscape level, landscape scale. I'm not going to run it, but I'll show you our FVS interface. So it's very similar to the stand level where you bring in your FVS information. One thing that's great is, let's say you have a massive landscape with a huge tree list. You don't have to run every single stand through. You can actually run stands that you select with ArcMap. You can specify prescriptions within stands and run just those. Or if you wanted to test a single stand, you can run that, or a set number. So let's say you're just testing a new prescription and you only want to run 10 stands through. You can limit that to save computing time. The FVS options within the landscape are the same as the stand level. You can pick your cycles, you can pick your fuel models, you can create those tree lists for a set year. You can also, which I didn't mention before, you can turn on and off the fire and fuel extension reports, such as the burn report, as well as the fuels report. You can also turn on and off carbon reports. So if you're not interested in carbon, you don't have to output that, but if you are, it's hardwired, which is great. So there's going to be, I guess I'll show you next a little bit about within the build LCP. So there are multiple ways of building landscape files within ArcFuels. One is using that FVS data. So if you ran the landscape through, now you could build an FVS file or a landscape file from that, or using grid data or merging multiple data sets. I'm going to just show real quick the one using grid data. Again, just because of time, I'm not going to actually build the landscape file itself, but show you the form. So this form lets you set up your information. So you'd have to load from your ArcFuels table of contents the different files needed. So for example, elevation, slope, and aspect. So defining your topography, as well as the units. Don't forget your units, they're very important. And then there's also the fuel model, canopy cover, canopy height, canopy base height, and bulk density. So those 8 layers that make up the grid sandwich to run FlamMap and FarSight. So if you only wanted to build an existing conditions landscape file from here, that's all you would do. You would go to your outputs. You can either make the landscape file be the same extent as your whole landscape, or you could use another layer to limit the extent, just like I had the fire layer in there. If you downloaded too much data and you've got your sub area or small area that you want to do for analysis, you don't need to go through and clip all your grids and convert them to ASCIIs and build your landscape. You can just use that to mask it and clip the landscape file. You can also output ArcGIS grids as well as a landscape file. So let's say you're doing this from FVS data and you don't have the grids already from FVS data. It's a great way to create them and store them for future use. The other thing that's great here is you can actually apply treatments. So I'm going to close this out and just show you where my treatments are, just so you have a visual. So in this screen now, you're seeing a landscape that is basically all the stands are outlined still in black, and then we've got a treatment prescription that has 3 different treatment types in yellow, blue, and green. So any stand that is one of those colors is a stand that had been deemed necessary for treatment. How that was decided is, it just varies from landscape to landscape. But now I'm going to go back, and I want to actually build a landscape file this time that treats those stands without having to manipulate all the grids on my own. So I would use this Apply Treatments Adjustment box, and then I'd look for the Treatment Adjustment Database, which is something you would have built beforehand. And then I need a link information so it knows not only where to treat within the grid, but also how to treat. So I'm going to pull in the treatment location and treatment type grids, and these are all supplied within the demonstration data, and there's information on how to build your own. And then within the database, I need to find my actual treatment adjustment table, which, so you guys know, this is a very simplistic treatment adjustment table. At this point, we only have 3 different treatments going on for that blue, yellow, and green. And within the different colors, we're going to either change the fuel model to a 181 or 182. We're going to do adjustments to all the other metrics of the canopy cover, base height, and canopy bulk density, and these are multiplication factors. So it'll take what you started with and then multiply this by a value. So for example, a canopy cover adjustment of 0.9 multiplies your value by 0.9, which means you have 90% retention or a 10% reduction. So then within this, again, now that I open the form, I need to link those lines from the treatment and adjustment fields to the different database. And then from here you can build the landscape file and output the grid. So that just saved a lot of GIS manipulation as well as creating grids. And again, you can do it for the whole landscape or you can shrink it down. For time, I won't actually create the landscape file, but just wanted to show you that's there since it's one of the more powerful tools in ArcFuels in my opinion. Really quickly, I was going to show you that even though we don't have Flam Map integrated like the WFAT tool, we do have ways to link to and just open the programs externally. So I'm clicking on the Wildfire Models tool now, and I'm just going to open Flam Map, which is just quite simple, just showing you that you can link to these programs. You don't need to go to your My Programs to open them. It's just a quick and easy way to access commonly used fire modeling programs. And then let's say we wanted to do some post-processing. We'd gone through, we'd done our Flam Map. We want to convert these different files and bring them back in. There's tools for that in ArcFuels too. So I'm going to go under my tools, and I'm going to batch convert some of those ASCII grid files, which are the output files from Flam Map. At this point, it's great because I don't have to individually do them in GIS. I can grab a bunch of them at once, project them, and map them in one step. So right now I just added 3 output files, burn probability, crown fire activity, and flame length from a run that I had done in Flam Map, and I'm going to convert them. So it just converted those 3 files quite quickly for us. There's also tools if you wanted to show how they display them differently within the risk tools. We've built in kind of a display system. So under risk, I'm going to just change the display. And these are things you can do in GIS, but they're very helpful to do outside of GIS as well, or outside of the tools built into GIS using ArcFuels. So I just decided to change so I could see the ramp of burn probability from low to high, where red is now high versus green is low values. I can also look at, we'll change flame length so I can highlight areas where it exceeds a set distance. I'll go with 2.4 meters, which is about 8 feet. And then I need to turn some layers off so we can see that. So now it highlighted areas in green where the flame length did exceed that that 2.4 meters, or red where it was less than. This doesn't actually manipulate or change the grid itself, but it's just a great way to visualize it and map it. And then finally, I just wanted to show you one of the tools within the risk toolbar that uses the Flame Map 5 specific outputs. The first thing I'm going to do is I'm going to convert a fire size list, and a fire size list is those individual points. If you were to do a burn probability run, it's not only the location where the fire started, but then the fire size itself. So I'm just navigating to open that Flame Map 5 fire size list file, which is just a text file of X, Y, and size. I know the input source was Flame Map. There's also one for FSIM, or if you wanted to input information from like plot location, you can do that as well, defining the X and Y location headers. But I'll go back to Flame Map. I'm also going to project it when I map it. This does save time, because normally you would have to first add XY data as event data, then export it as a shapefile, whereas this just in one step adds these fire size list files. So the fire size list files now are those dots on the screen. I'm going to turn off the treatment so you can see them. I did a quick run, so there aren't very many fires out there, but it does do that conversion. And then one last thing I'll show you before I stop for questions is one of the tools within risk that averages information. So I'm going to go to my risk toolbar again, and then I'm going to go to averages, and I'm going to look at averaging the fire size list by the fuel treatments themselves. Granted, because I did so few fires, this information isn't going to be, you know, amazing, but I'm going to use a pre-intersected layer that intersected the fire size lists with the treatment unit, so each fire itself has information about what treatment unit it fell within, and that's based on stand ID. And then I'm going to have it output into a spreadsheet. So once it runs that, sometimes you get a warning in Excel, but it opened Excel and it told me not only, it gives me information about the polygon ID, which was the stand within the treatment, and then the average fire size, as well as the average fire size overall for all the stands. So because I did so few fires in a short running period, my average fire size was only 31 acres. So with that, I'd like to point out again our website with the listserv, which is of great interest, and I have time for questions if anyone would like to ask questions.
Okay, well, thanks, Nicole. That's a really powerful set of tools there. That's pretty interesting, especially to non-GIS folks out there. That looks really, really cool. There's a couple questions have already come in, so everybody else get your questions in, and we'll try to get to them. The first question is from Hilton Haynes, and he asks, are the base models used in ArcFuels rule-based, empirical, or physics-based?
We have a mix of models, so we leverage everything that's out there already. We didn't create anything new. So FES in a way is empirically based. I'm not sure exactly what Flame Map or Farsight are, but within the system we didn't invent anything new, so knowing the assumptions of all the models is really important. But there's no physics-based fire behavior models incorporated right now.
Okay. Don Falk has a notes that some areas inside the fire didn't convert to 181. There seems to be other fuel types that you didn't specify. That came in a little earlier. I think that was from that one of those first ones you did.
Yeah, I just told it to change 165 to 181. If you wanted to change other fuel models to different things, you can do multiple changes at once. You're not limited to one at a time, so you could do a big change.
Okay. Joel Carson asks, will ArcFuels 10 work in a 64-byte system?
As long as GIS works, it'll work.
Okay.
GIS is kind of the limiting factor sometimes with this.
Right, right. And I'm sorry if I messed up the name, but Ioannis Mitsopoulos asks, does ArcFuels allow the user to create custom fuel models, or just allow the user to insert LCP files created in FlamMap or Farsight?
So you can use custom fuel models. You'd have to design them outside of the program itself, but just like you would with when you run FlamMap, you could build an LCP with your custom fuel model, but then you need to have that custom fuel model file associated with it, so it knows what custom fuel models are doing, what they mean, what their loading is, etc.
Okay, all right. Well, that is their. We'll give them a couple moments for a question. Oh, here we go. Okay. This is Ana Barros from Portugal. First off, thanks for the nice presentation. I'm interested in applying this to a risk assessment in Portugal. My question is, are the risk tools independent from FVS, which is designed for the U.S.?
Yes, the risk tools are primarily coupled with FlamMap at this point. So it uses information about the burn probability and as well as the intensity. We tend to couple that information with FVS, so we have linkages between flame length and tree mortality per se, or flame length and habitat loss, which are easy to calculate within FVS. But if you have another means of associating expected loss or impacts without FVS, you can definitely use that as well.
You just have to have another database or something to link it to there?
Yeah, you'd want to have other information to do it, but it would be doable. It might be a little tricky to set up, but I could help with that.
Okay. Mark, I don't know if there's any upcoming ArcFuels training opportunities, and if so, when and where?
So they're kind of on an as-requested basis. I'm hoping I put in a proposal to give one at the AFE Fire Conference coming up in Portland in December, so that would be an 8-hour, one-day course. Otherwise, contact me and we can talk about getting a training going if there's a large enough group in your area.
Okay. Tate Fisher says, great presentation. Concerns have been expressed that when coupling these programs, the algorithms may be affected and therefore not produce accurate output. Your thoughts?
There are limitations with all the different modeling systems, so you might compound errors on one on another. So if there's errors associated with FVS and the modeling into the future, those are going to compound with the known limitations and errors with, let's say, FlamMap. So it's just understanding your limitations and trying to minimize the amount of error associated based on the models themselves and bringing in, the best data you can, because what you output is a relic of what you input into the models themselves.
Okay. Alan Ager wrote in for a comment based on the question earlier about the 64-bit systems, but he says there are 64-bit fire behavior for some models, but not all. FlamMap 64 is available, but not FVS.
Thanks, Alan.
And then Hilton Haynes asked a question. If you have an ArcMap background, what is the learning curve to adopt this tool? Yes, that was one of my questions. How much GIS would you need to get started on this?
Having a basic understanding would be very helpful, but we have created kind of a GIS help guide for people who are a little weaker, but knowing how to add data, understanding how to, the differences between grid data and shape files is very important. But we try and outline in the user guide, there's a lot of screenshots, there's a lot of information to try and help people who are struggling with GIS, but if you've never used GIS before, I highly recommend pairing up with someone who's more familiar with the program itself to save a lot of frustration and time.
Right. Okay, another comment from Alan. Coupling the models has no influence on the model outputs themselves. Okay. Another question from Rich McCrea. Will ArcFuels output KMZ files?
Not directly, but I believe as part of ArcMap and ArcGIS you can do that. That is something I'm not positive on, though.
Okay. Alan writing in again, to Anna from Portugal, is responding to her question. The risk analysis is specific to FLAM map and FSIM. Okay.
And FSIM is, I just want to clarify, is FSIM.
Okay.
But it also works with the new FLAM map 5 that is also similar to RANDIG as well.
Okay. Yeah, this is definitely outside my range of acronyms.
That's okay.
Joel Carson wants to know if is spatial analyst required for ArcFuels?
Yes, it is. That is one extension you need to have to be able to do a lot of the raster manipulations.
Okay. Anna Barros from Portugal again asks, will ArcFuels recognize any projection system included in ArcMap?
Yes. As far as I know, it will. As long as you have it in there and you can define the projection, it'll use whatever projections in ArcMap.
Okay.
Yeah.
And then Alan again says ArcMap will output KMZ. All right, and that's all the questions we have. So Nicole, I appreciate it. It was very interesting. I've heard about ArcFuels for a long time, but I've never seen a demonstration of it, and I really see that it's a very, very powerful set of tools. And so we appreciate it. And if you're out there and you would like to, if you think you know someone that might be interested in this presentation, I'll have the link up to the recording. It takes about 30-45 minutes to get it ready. And you can pass that link on. It'll be on the Advances in Fire Practice webpage. And with that, I guess we'll bring it to an end. Thanks, Nicole.
Great. Thank you, guys. Thanks for attending.